Hey everybody, I hope I'm live now and I haven't made any mistake. If you're there, it's very hard for me. I think this is just a new setup for me. That's different from fast book or paper reading groups that I've had before. But if you are there, then if you could please go to that link 1dpe.me/resnet. So let me see if I can paste that in the chat somehow. There we go. And I click send. So if everybody could go to this link, 1dp.me/resnet, and I'll go there too in a tick. And it would be wonderful. I'd really, really appreciate if we could please carry on all the conversation here. And I'm making this request more than normal. Like I'm making this request more than Fastbook or paper reading because I really have to go in to this live streaming tab and then have a look at the chat. And it's really a bit hard for me to do all of that. So if I go in here, could we please make sure to carry on? Okay. So that's that. So then I guess there's already this live streaming link. I've tweeted about it. And what we're doing today is then this, we're training ResNet, we're coding ResNet from scratch. And when I say we're coding ResNet from scratch, I actually mean it from scratch because you're gonna see me, make errors today. I'm pretty sure of that. And you're also going to see me, like I haven't prepared much for this. When I say I haven't prepared much, I mean I haven't prepared anything. Like usually you'd come into an event and you'd have done a week of preparation and then you'd host the event. But times are such for me that I haven't had a lot of time and I haven't had a lot of time on my plate. But the time that I've had is I thought I'd do like a live coding session on ResNet. And what we're going to do today is we'll go through the paper and we'll match everything in the paper and we'll try and code it from scratch. So you'll see me do things that you won't normally see otherwise, which is both a good and a bad thing, I think. So for example, right now, what I'm doing is, oh, I don't need that. Sorry, 1 second. For example, right now, I'm just setting up my SSH, which is something you won't see. So I just need to stop share for a quick 1 second, just to get the SSH key, which is private, which I can't share publicly. So just give me 1 sec. I'm hoping we're still live. I've almost got it. Okay. Should be fine now. Oh, where did the Zoom go? Ah, there you are. Okay, can everybody see my screen again? If you can, that's great. So if I go in here and I just paste that, and now if I say SSH AA Asia, that should let me through, I hope. It does. Cool, so I've got my instance set up. I could have also done Google Cloud Platform, but I'm just doing it on GCP at the moment. So I could just now start a tmux inside, and then I could just run my Jupyter notebook on a specific port. And then if I go to that port, that should let me run my Jupyter, hopefully. Okay, it's asking for security token. So I can just copy paste this in there. And hopefully that works. It does work. And now I can just go in to say maybe Git repos. I can press Control B and apostrophe to create another tab. So now this is the benefit of Tmux, and because we're live coding and this is basically a coding heavy session, I'm going to show some of these tricks that I use that I pretty much learned from Jeremy actually the first time, and they've stayed. So I don't came. So I've just got now my 4 piece space to set them up properly. Yeah, that should be fine. And now I can just go to cd git repos and I can say create a new directory, which is say live coding PRG. And then I can go to that live coding PRG and I can say create ResNet. And now I can go to that over here. So I can go live coding PRG, go ResNet, and I can create my first notebook. So if I create my first notebook, that brings me here, and I can call this ResNet. Okay, so we're set up. So I can now import things here. I hope I can import Torch. And I can import FastAI. Not that I need it. I'm just checking. Everything's working as normal. Can you bump up your font size a touch? Of course, sure. How about that? Does that make things better? Done that? That should be better, I hope. All right. So I'm just gonna now close this, close this, close this. Check here. Okay, there's still people here, so everything's going fine. I hope. All right. So we're just gonna carry on with our conversation over here, and now all I need to do, increase the font size, please. I'm really sorry. I further increase it more. That would be too much if I zoom in a lot. Hopefully that's fine. Thanks, it is good now. Okay, great. Oh, Alan, are you joining us from Australia? And it is, isn't it like, what time would it be there? 3 o'clock? Are you joining us at 3 a.m.? If you are, I'm really, really thankful. Okay. And also really sorry for moving to a non-Australian friendly time zone. All right. So now then, what we're going to do is we're going to code ResNet from scratch. And my go-to place, oh, actually, I don't have my Visual Code set up. So I need to set up Visual Studio Code as well. That's another thing I want to set up. And for that, I'll have to just stop my screen share again for a tick. So give me 1 second. So if I go, I don't know why I keep closing my video actually. Just give me 1 second. That should be fine now. So I'll have to do now, I just need to set up, go to my GCP private account, find the external link, which is just coming up in a second. And I really need to fix the lighting. I think I haven't hosted much events in India, so I just need to, I'm still finding my feet. If that makes sense. All right. Oh, I'm sharing this, which I shouldn't have. Never mind. We'll cut that off. And I'm going in this instance, and I could copy paste my host name. And now if I say connect to host, and I say that particular host for which we just pasted the key in, and I click continue. That should work, I hope. And let's see what this is saying here. Okay. Yes, 3 a.m. I'm dedicated. That's great to hear. Thanks for that. Next to this, I needed this session for ResNet. Oh, great. I'm really no, thanks for everybody for joining. Will you also take up coding from scratch and setting up the EC2 instance? Jeremy did discuss it very briefly. That's not something I do plan to do as part of this session about the EC2 instance. But if needed, we can have a look in the future session. So what I want to do is going forward, like we're doing Fastbook on the side, and we're doing paper reading group on the side, which is more theory, like less coding, and something that's been on my mind is like we want to do more beginner friendly coding sessions, and Sangyam's PyTorch group. If you haven't seen that, I think if you go to our forums at Weights and Biases. Oh, by the way, they're out of beta, so Sangyam's PyTorch book reading group. Yeah, that's the one. So I think Sayam Bhutani, my colleague, he's hosting this PyTorch reading group, which takes you in PyTorch. So I think this is another great place to get started with PyTorch. And then in this session, I'll be using PyTorch. So we're connected to our instance now. So then the one repository that's always helpful is PyTorch image models. I've been a contributor to this repository, although I will admit I haven't been very up to date with what all Ross has been up to. But say a couple months ago, I did contribute to this repository. When I say I did contribute, I contributed a couple models, which is Convit and ResNet RS. But there it is. Like this repository has everything. So it's got like if you go in PyTorch team models, there's like an implementation of hundreds of models. So I don't really need to look elsewhere. And I trust Ross's implementation because it's tried and tested. And then he adds pre-trained weights and everything. So I'm going to be referencing this library a lot, like I always do. So I'm just going to go here and I open that repository. So if I say PyTorch image models, there we go. And that should open up that repository. So I was looking at MLP Mixer. And I need to zoom in a bit, I think. And now all I need to do is Git Pull. Okay, so what Git Pull does is it makes sure that I have the latest version of the repository. Yeah, that looks fine. That was the last commit. So we're at the latest version, which is great. And now I can go in Tim, I can go in models, and I can go in ResNet. And there it is. I have an implementation of ResNet. So this is Tim's implementation and Tim's way of doing things. When I say Tim, I really mean Ross. And I can just press Control K, Control 0 on my keyboard. And now things are slightly bit easier for me to read. There's a basic block, a bottleneck block, and we will see what all of those things mean. So we're going to try and actually first implement these things from scratch first. And I'm pretty sure I'm going to fail terribly at doing so because I haven't had much practice before this session. But when I fail, I'm going to come back to this. I'm going to come back to this implementation of ResNet, and then we're going to try and fix things. So then you have this ResNet model. Okay, so let's see if there's still any questions. I've tried to keep up with PyTorch group, but couldn't. But the coding part takes time. How should one use the notebooks? Should one try to replicate them? It would be really helpful if you could help us in setting up the EC2 instance in the session. Okay, yeah, sure, I will do. These are points that I've noted. In terms of notebooks, yes, you should definitely try and replicate those notebooks, which will be really helpful. Because that's something that helped me. Okay, so I'm just going to bring up actually, let me go in this another tab. I'm just going to bring up the ResNet paper. There it is, Deep REST learning. So let me have the paper open here. I'm just going to click on PDF. And there we are. I'm going to zoom in a bit again. I think that should be good for everybody. And that should be it. Okay. So then the one thing we saw in our paper reading group is that what ResNet does, like in a traditional convolutional neural network, like before ResNet, all you had everything going through the residual path. But what ResNet does is it adds this skip path, right? And there were two different ways of doing this. Like this is what a ResNet 34 look like. So you have your input image. The first thing you have is your 7x7 conv, which is 64 channels. And I think that means stride 2. I think that means stride 2. I'll have to confirm. And then you have a pooling layer. And then you have your first block, which is 3x3 conv, 3x3 conv, so on. So you have like repetitions of. So it's 3x3 conv and then 64 channels. And then suddenly you go from 3x3 conv to 128 channels. Again, stride 2, I think. What does that mean? Does it say anything what that /2 means? I'm assuming that's stride 2. There it is. We perform downsampling. Plain network. Okay. Plain baselines, figure 3, are mainly inspired by the philosophy of VGGNets, which was an architecture before this. The convolution layers mostly have 3x3 filters and follow two simple design rules. For the same output feature map size, the layers have the same numbers of filters, the number of bodies doubled. Okay, all good. I think that means stride 2. All right. So then the main things that we saw, okay, why is this sidebar still here? Lock, small, automatically hide in tablet mode, automatically hide in desktop mode. What if I click on that? Okay, cool, that's gone. If I, oh, how do I find it now? So if I go maybe that, does that help? No, I've just made a fool of myself by trying to, no? Okay, this is, well, I've got everything in front of me, so I guess it's fine. I don't really need the taskbar right now. I'll just continue like this. Okay, so then we were at this point where I was, at least now there's no sidebar on the left, which is good. So then I was at this point where this is what ResNet 34 looks like. And now what we want to do is we want to try and implement this 34 layer residual. So the one thing you can see, the one repetition is a conv followed by a conv, and then there's a skip connection between the two. There's a conv followed by a conv, and there's a skip connection between the two. There's a conv followed by a conv, and there's a skip connection between the two. And then every time there's a, so like at this point, the output would have 64 channels, and then every time there's like a change in the number of channels. Because look at this. Let me just actually copy paste this to 34 layer residual. So let me just take a screenshot of this. I don't need this. I don't need that. I'm sorry, 1 second. I'm just taking a screenshot. So if I take this screenshot and I paste it over here. So the point I'm trying to make is you have one conv and two convs, and then you have a skip connection. So like this is a block. If you look at it, it's a block. I'm just going to call it B. And then this is again, let's say this is B1, B2, B3, right? So there's 3 blocks of 64 channels. Then there's 1, 2, 3, 4. 4 blocks here. So see this? That's 1 block, that's 2nd block, 3rd block, 4th block. Same for this one. There's again multiple blocks, right? There's 6 of them. This is 6. And then over here, there's 3 of them. So I guess the point I'm trying to make is if we can find a way to implement this basic, there's two blocks that or there's like two different variations of the block that we need, is like at input, if this, let's say, let's just look at this one, right? My input has 64 channels and my output has 64 channels. So I can really add the two together, which is okay. But in at this point, my input has 64 channels, but my output has 128 channels. So I can't really add the two. And remember what we had to do to make both the channels the same is like you needed a 1-by-1 conf over here to make sure that the number of channels in the output and the input are the same, so you can add them. So that's the one thing that we really need is this basic block, or this like this is the tiniest part of the whole architecture that we want to start with. So let me see if there's any questions so far. And questions were in this tab. Sharing the repo referred in the beginning. Thanks very much for doing that. Okay, so then the first thing that we need is that basic block. And I'm again going to reference Tim because I'm myself, I don't trust myself, and I trust Ross a lot more than myself, and I trust his implementation a lot more. So you can see now, if we go look at this forward method, right? You can see what you have is this basic block is this, all of this. Oh, sorry, let me just close this init. So all of this code is just the implementation of this particular conf followed by conf, and then there's a skip connection between the two. So you can see how that happens, okay? And this conf2, you have batch norm layers. I think we could make this cleaner, like we could have had a conf batch norm, but let's just leave it like this. And you have an activation. And then you don't need SE, you don't need drop path, you need a downsample. And you just add the two. Okay, which is great. I'm just trying to see what Ross has done here. Downsample is this, self.downsample. Okay, makes sense. Cool. I guess that's the easy part. All right. So let me go to this thing. So I'm going to call class. I'm going to call this a class basic block. I'm going to import torch.nn. I'm literally replicating, well, trying to replicate what Ross has done. And I'm trying to be more vocal, and I'll try and explain everything that I'm doing one by one. So in PyTorch, you have, if you inherit from nn.module, any architecture that you implement that needs to have parameters, because remember, if you're joining me from Fastbook, models have parameters which need to be trained and everything. So in PyTorch, the best way to do it, or like to tell PyTorch that we're creating an architecture that's going to have parameters that are going to be trained, is by telling PyTorch to inherit from nn.module. And now automatically it has all those features, like it has parameters, it has a forward method, and all those good features that you need. So I just go, what do we need here? We're just going to need, I guess, in channel and out channel. Is that all we need? Oh, there's a lot of things that are being put in here. Do we need all of that? No, I think in channel and out channel, right? In planes and out planes. And we would need a stride. Yeah, we would need a stride. And I guess that's it. Like, that's all we need, I think. Like, that's the only three things we'll need to implement the very easy versions. I think that's all we need. So I'm going to call it in planes. So I'm just going to call it in channels, and I'm going to call it out channels of this basic block. Remember, what we're trying to implement is just this, is just this much of the stuff. So you have conf1 and you have conf2. Like, this is conf2, this is conf1. In between you have batch norm, and you have an activation layer, and that's pretty much it. So okay, so I guess we just need in channels, out channels, and That's okay. So if in channels is not equal to out channels, then self dot downsample equals true or nn.conf1d, and you'd have to go from in chance to out chance. Okay. All I'm saying is like if the number of channels is not equal, then we need to have like we need to have a conf1d in our skip path. So that's something we discussed last time. And we could also do this for feature map size, but let it be for now. So self dot in chance, do we need any of that? Actually, we don't. So self dot conf1 is this one, 3x3 conf, nn dot conf2d, in chance to out chance, in chance to out chance, and the kernel size is equal to 3. Self.conf2. It's very much possible that what I'm doing is completely wrong, but I promise you one thing: by the time we finish, it would be right. So I'm just trying to show you. So now we just have set up our two convolutions, right? Because all we need is like the first convolution, and then we need a second convolution, and then we need a batch norm. So I'm just going to call it self. I wonder why Ross has like a batch norm 1 and batch norm 2. So out of curiosity, let me just have a look. Okay, after conf2, there's also a batch norm. Interesting. Okay, so we're gonna follow that. So let's just call it. Is it nn.batch norm? Is it what it is? Yes, it is. And you just specify the number of channels, correct? Let me have a look. Yeah, you just specify the number of channels. Cool. So self dot reduce first. Reduce first. Do we need something like reduce first? We don't. And do we need something like expansion at the moment? I don't think we do. So not really. Gonna skip that. Okay, so I'm just gonna call it nn, and I'm gonna say out channels here, and then it's gonna be exactly same. And then in PyTorch, you define something which is a forward method. So the forward method is what tells what you do to the input. So if my input is X, right, the first thing I'm going to do is, how does this say? Like it goes X. Okay. So the first thing I'm going to do is you pass that through your first convolution. So remember, you have your input. The first thing it does is it goes through the first convolution, right? So you have some output, then you add batch norm, I think, which does that. Oh, first you save this in shortcut, right? Because that's your input. So then this goes through the first convolution, which is this one here. Then it goes through. It needs an activation, so maybe call it ReLU. So self.act is nn.ReLU. And then it goes through the second convolution. It goes through the second batch norm and goes through ReLU again. And you return shortcut if self.downsample shortcut equals self.downsample shortcut. I'm assuming, I hope what I'm doing is right. And then you return X plus shortcut. And generally, let me just do this. That's not a good way of doing it, is it? If in chance. Okay, that's a better way. So none, so self.downsample is none if the number of in channels is equal to out channels. Because if the number of in channels and out channels are the same, then you don't really need to have a downsampling convolution. Otherwise, you have a convolution 1D that goes from in channels to out channels. I think that should be it. I think that this version should work. And I could have had like, even this could have been a conf, even this should have been a conf layer. So let me define this as define conf block. How about that? And I go from in chance to out chance. For everybody wondering, is there any questions? Like I'm just coding right now. Shouldn't downsample be a conf to the instance? Yes, it should be. Of a kernel size 1. What have I done? Have I called it conf1d? I think both could work actually. Why would both work and why would it not be? Well, I've usually seen the number of channels being changed using conf1d. Okay, let's keep it 1D for now. Let me see what Ross is using, if he's using downsample. Downsample, here it is. And self.downsample equals that. Okay, so that gets passed somewhere. So at which point does it get passed? I just want to see something, what Ross is doing, and then I'll try and answer that. So downsample is equal to 1. If that, then downsample, there's some quarks, and there's downsample conf. So average down false. Downsample conf, which is what? I see. This is how Ross has implemented this. Nice. Return and end of sequential. Okay, he's also using a conf 2D, and then the kernel size would be 1. That's what I would assume. Yeah, I guess you're right, but then even 1D would work. Well, okay, never mind. Let me just keep it like that for now. Okay, so that's that, and that's that. So that's my basic block. I will try and simplify this later. I guess let's just keep things. Let's just write terrible code. Is all I'm doing. Okay, so now I have something. I hope like this is something that is a replication of this figure 2, right? This is what's happening. You have your first weight layer, which is conf1, so that's weight layer. Then you have your second weight layer, which is this one. In between, you have batch norm activation, so batch norm ReLU, and then you have batch norm activation, and you add the two together, right? So let's test this. So let's just call a basic block. Let's just say we're going from 3 to 64 channels. Oh, would that work? Can we just go from 3? Let's just go from 64 to 64 for the first try. Do I need to check like the YouTube live stream comments as well? Are you guys by any chance? I think you need a super.init. Of course I do. Yes. Thanks very much for that. I do need that. That would have popped up. So this is what happens if you don't code for 2 weeks, which is what's happening to me. I'm being rusty. Super. But I'm really impressed with you, Alan. Even at 3 AM, your mind's sharp. Great to see that. Blocks, I'm going to do block, basic block. And let me say my input is that. Do I have torch imported? I do. So let's say that's one image of 64 channels of 1 by 64 by say 128 by 128. I don't know. And then what if, does that work? Runtime error. The size of tensor 124. Oh, I didn't add padding. Padding equals 1. Does that work? It does work. Okay. Woohoo. So something's going on. Let's see. Does block have a downsample? I think it's going to be none. Correct. Okay. And if I did I went from 3 to 64, would that work? It does work. Okay. And then in this case, does block have a downsample? It does. Okay. I guess that's the first block that's been sorted. So we just got the block sorted. That seems to be working fine. I'm just going to keep this there. Okay. So I'm just going to copy paste this. Would that work? Oh no, I'll have to save that as an image and then upload that image if I want that to be a part. But basically, could I do that? Does that work? Oh, it does work. Okay. Nice. All right. So all we've done in this one, this basic block, is just a replication of that at the top. Okay. Looking at more questions. Doesn't conf1d introduce new parameters while ResNet is supposed to be fx plus x? Oh, it's not a stupid question. Basically, if you read through the paper, there's a point mentioned somewhere, like it's meant to be f of x plus x, right? But your x is now going through conf1 first, and then it's going through conf2, and then you have the output, which is f of x, and then you add the two together, right? But what if the number of channels in f of x is different from the number of input channels? In that case, before passing this, you need to pass that through a conf2d of kernel size 1. What that will do, what does that mean of conf2d of kernel size 1? Well, what's the difference in conf2d and conf1d for starters? Conf1d basically means it's just going to go in one direction, which is that. Conf2d means it's going to go in two directions, which is height and width. Conf3d means the kernels are going to go in three directions, which is height, width, and basically depth. So if you have, say, actually, that must be, this is a separate thing that I want to explain. Kernel size is something that we've looked at in Fastbook so many times. I think I explained that in week 12, was it? Can't remember, but if you have questions about all of this, just have a look there. But the point I'm trying to make is, like, if the number of input channels is different in the output and the input, then in that case, you need to pass this through a convolution. Like, you need to make the number of channels the same. And the only way to do that is either use a conv or use an nn.linear. And we're just going with conv because that's what process used. To begin with, I think the second ReLU needs to be at the end after the addition of the shortcut. Is that correct? Let me confirm. You are so right. X plus shortcut and then value. Oh, there it is. Yes, it is there. Sorry. Thanks for catching that. See, that's the error that we wouldn't have known about. We won't have known about if, yeah, we won't have known about this. But I'm just thinking, why is this called Act 2 and Act 1? That's my, just in case, I guess you can have different activation layers, I would assume. Like, Russ is really good at letting people use like a ReLU in the first time, and then, but we're using ReLU both times, so we're just going to call that. So I'm just going to say x plus equals shortcut, and then return ReLU self.add x. That would work, or should I just do it like that? I think that works. Yeah, cool. Okay, so that's the basic block. That's that. So that's the ResNet basic block. Now what we need to do is, in the ResNet architecture, right, which is, if you keep going through this, we have tested various plain residual nets. Oh, I was looking at the comments. This is where you explain convolutions really nicely. Oh, thanks for that, Vinay. I'm doubtful about the really nicely part, but yes, I did make an effort to explain convolutions. To begin with, that entity Yeah, there's a pooling if stride is anything other than 1. Well, we're mostly going to use stride 1, but there's I think there's a point where there's stride 2. So let's have a look at how Ross does it, and then we're just going to try and mimic that. But because we're doing things like this is a great way that I've found to learn things, is like, sure, use an implementation as a reference, but then also try and like when you like this process of what I'm doing now is like implementing basic block from scratch. When I'm doing this, things are becoming a lot more clearer in my head. Like, okay, in ResNet, this is exactly what happens. Like, I missed padding here. My value was at the wrong place. I had the patch down, like this. There were these issues, and I was using a conf1d instead of a conf2d, which won't have been that much of an issue. But I'm making all these errors, which now in my head, now after fixing them, I just have a better understanding of the basic block. Okay, I'm so reading through. So now what we need is like in the complete ResNet architecture, when the image comes in, you need a stem. Well, that's going to be easy. It's just a 7x7 conv, which changes the number of channels from 3 to 64, and is also stride 2. So let's have a look at the ResNet implementation. There it is, ResNet. So we go through and we have a look at forward first. Okay, so it's going through self.forward features. Forward features is going through conf1 and deep stem. We don't need to use deep stem because that's a different setting, by the way. There's a stem type default, the type of stem. Default, a single 7x7 with a bit of stem width. Yes, that's what we want to use. So Ross has like in the implementation of Tim, actually by doing this, I'm also showing you. So I'm just going to call that. So let's see if if I'm implementing ResNet, right? Class ResNet. I already have my block. So the first thing I need, I can't do that. I need to have an init first. Self. What do we need here? What parameters is Ross passing? He's passing block. Okay, so that's the block type. He's passing layers, so that would be like 3463 or something like that, I would say. Yes, and num classes and in channels. I guess that's all we need for now to implement our version of the ResNet. I guess if there's anything, we'll start with just this, and that should be it. Okay. So does it say? I'm just having a look at what's things. I'm just going to say self. You need a super dot. I'm now going away from like having my. I'm now calling this stem, which is meant to be nn.conf2d, right? It's going to be this. And I'll tell you what I'm doing here. I will explain. So it goes from in chans to in planes. Ooh, that would be 64. And kernel size 7, stride 2, padding 3, and bias false. Yes, that all looks good. So you're going from 3. Okay. Well, Ross has called it in planes as well, but in our version, is that ever going to be different? I think the stem always remains the same in all of. Yeah, it does. So see, now I'm just having a look at the various ResNet architectures. So the only difference in ResNet 18 and 34, you have this basic block. And in ResNet 50, 101, and 152, you have this bottleneck block, right? So that's the difference. Like a bottleneck block first uses a 1x1 conf, followed by a 3x3 conf, and then a 1x1 conf. I'm going to explain the difference in the two in a tick, but right now, like all of this preparation that we're doing is say it's going to be fine for 18 and 34 layer ResNet. And the first thing that you have is this conv1, which is 7x7, 64 stride 2. So actually, instead of calling this stem, let's also call this conv1 because that's what it's called in the paper. So conv1 is an nn.conf2d, which goes from number of input channels, which was actually 3, and it goes to say 64, kernel size 7, stride 2. Okay, so if we've implemented this bit, right? Now, for the 18 layer, let's say we're implementing ResNet 18, we need 2 of the basic blocks, right? And then we need 2 of this basic block that goes from 64 channels to 64. This one goes from 128 to 128, like basically 128, then 256 and 256 and 512 and 512. So we need to be able to implement this to implement ResNet 18 correctly. So how can we do that? How can we do that? See, if I would come in prepared, I would like say, oh, okay, and we can do this by doing X. But right now I'm thinking, how can we do that? Is we need a way to create blocks. And I know, so we need a way to repeat the basic block twice over here, right? Because it's just a conf followed by conf. Okay, 2 of the basic blocks here, 2 of the basic blocks here, 2 of the basic blocks here, and 2 of the basic blocks here. Okay, so I'm just gonna say, and this looks like 2, 2, 2, 2. So if I just say, yes, if I just say create the block, okay. So I'm just gonna say define make blocks. You pass in block and you pass in layers, which maybe looks something like that for ResNet 18. And then you go, how does Ross do it? Let's just have a look. I'm just going to have a look at how Ross does it. So you have something called channels, right? So you're going always from, you start with 64, 128, 256, 5, and 2. Yes, that looks correct. So you have something like that, which is great. And then you call something, then he calls in make blocks, and you pass in the block and the channels. So let's have a look at this make blocks function. So you go from stage index, stage name, stride, and all of that. If net stride is more than equal to output stride, else this, down sample, down quarks. Okay, yeah, that should be fine. And then return stages and feature info. Okay, we don't need feature info. What did I do? So I guess I'm just trying to see exactly what Ross is doing, repeat blocks, and then combine with an nn.module list. Yes, that's one way of doing it. I just want to see like how Ross is doing it, because I really follow Ross's implementations blindly. That's how much I trust his implementations. I'm just having a look because he's even setting like the stage name layers and stuff, which is nice, I guess. Never liked this name with compatibility. Yeah, because it's like this implementation is able to just read the, it's just able to read the, it's able to load the pre-trained weights as well. I just want to have a look at just one quick thing. Then you go from stage and stage modules, self.add module. I see. And what does add module do? Oh, okay. That's just that. Okay, that's just PyTorch. So you pass in the stage. Interesting. And your stage is, I'm just having a look again at the make blocks. And your stage goes here. You have a stage name, stride. Let's try that. Down quarks. Stride is unequals that. And you go block index in num blocks. See, blocks.append block function, and you attend nn.sequential. I see. Okay, interesting. Cool. I guess I've got the gist of how this is implemented. All right. nn.sequential is the way to go. The weird text code is still a little small for me. It might be a resolution. If I make it too big, it's really hard for me to read, but I guess I'll sacrifice that bit. Try and make this a bit bigger. Try and make this a bit bigger. Oh, by the way, hi Sam. I didn't know you're part of you're watching me struggle. All right. I think I have a gist. So what if so PyTorch has something called nn.sequential. In my blocks, what if I put everything in that sequential? And then based on that, I should be able to do it. Okay. So now if I go for num layer in layers, I did that wrong, aren't I? Page index. that's stage 0, stage 1, 2, 3 in enumerate layers. Let's call it layer name equals, what are they going to call it? Conf blah x. So conf, okay, I set up my layer name, and there you go. And I go, what do I need? I need to create 2 blocks now. So number of layers is 2. I need to create 2 blocks, but I haven't really told the number of channels. So channels is again 64, 128, 256, 512. Is that what the channels are? 64, 128, 256, 512, correct? And I go, I'm just following this again. Oh, I need to go back. So going stage, channels, enumerate zip channels, block repeats, drop block. Yep, that's what I need. So go stage index, planes, channels, that. Yep, that's what I need. So I'm just gonna call this zip layers channels, and let's just say stage index, comma, num layer, and num channel. That should be fine. So what am I doing? I'm going from stage index, got my num layers, which is going to be 2. I've got my num channels, which is going to be 64. I'm going to create my block. Oh, I'm going to go for blah in length range num layer. I can just say this like blocks. Correct? Am I going far so far? And then you can just implement that to stages. So I could just call that blocks, which is what is happening inside the stage index. You have a blocks, and you just go for block index in num blocks. Yep, that's the right way to do it. So you can just say for block index in range num layer. So instead of calling it num layer, process calling it num blocks, which should be fine. Yes. And now I just create my block, which is this basic block for now. And I can update that. Actually, I should call it a block function. I should use that as a, because we're going to change this to be, I should call that way. Just give me a tick, guys, and I will explain everything. All I'm doing right now is I'm just trying to replicate a minimal version of this make blocks function. So I'm just trying to use the configuration. I'm just going to use like the configuration. So like right now, I'm trying to create a function that can create both ResNet 18 and it can create both ResNet 34. So as you can see, it's using a basic block. Like it goes from 64 channels. Like the first 2 blocks are, the first 2 convolutions are 64, but there's 2 of these blocks. But in ResNet 34, there's 3 of these blocks. In ResNet 18, there's 2 of these blocks with 128 channels, but in ResNet 34, there's 4 of these blocks. So like instead of like having a separate, oh, ResNet 18, separate ResNet 34, I'm just trying to create like this function called make blocks, which is again a copy of Ross's implementation. And all I'm trying to do, I'm just trying to like create like a loop that does this. So if I just say blocks dot append block function, which is basic block, and that expects in channels to out channels. So how do we know the in channels, in planes? Yes, where is that coming from? Oh, okay. You pass that to the make blocks. Okay. So that's a good point. But then how do we go from layer to layer? I guess interesting stage. If in planes is not that. I think I'm complicating things too much. Okay, what do we need? We just need a function that can repeat it as many times as I want. Okay. So the first thing is going to go from 3 to 64, then it's going to go from 64 to 128, then it's going to go from 128 to 256. So my first one, so I can just go for stage index in enumerate channels are like that, 364, right? So you start with 3 channels, then you're going to 64, you're going to 128, you're going to 256, and you're going to 512, correct? And then you're going from this num channel in channels. So that's not going to zip properly because they're different. Okay, so you go if this is my first stage, my inchan is 3, inchans is 3, stage index 0th, first, 2, 3. Inchans equals 3 if stage index equal to 0, else num channel. That should be fine, right? Channels stage index. Else it's going to be channels stage. All I'm setting up is my stage index. That should be fine. Okay. So now if I'm in this in my first, it's going to select this one. Otherwise, it's going to select that one. I'm doing this wrong. So I'm going from 3 channels. So if my stage index is 0, like my first one goes from 3 channels. What I want to do here, how am I not able to make these things easy? I'm going from stage index 0, which is 3 channels. So in channels is 3, stage index 0, else. Should be fine. Blocks is that, layer name is that, blocks that append, which goes from in channels to oh, okay, never mind. Channels. That's what I wanted to do. Sorry. Stage index -1. Got it now. That's my in channels, and then that's going to be num channel. So it's going from that to that. Okay, that's fine now. And that's my block. So that's going to be 2 blocks, and then you say stages. I'm just going to create stages equals that. Ignore me for now, guys. Just watch me as I make these mistakes. Stages that append and then dot stages dot append and then dot sequential star blocks, and then you return. Let's see if that works. Let's see if that works. So I want to say make blocks. This should be, let's just say, why do I have a block and a block fn? Let's just use 1. And then where else have I got block in this? A lot of places. So I'm going, yeah, that should be fine. So I just say block fn is basic block. And does that work? Let's see what's the error. Name channels is not defined. Where? Okay, there. So that should be channels. That's that. Does that work now? Yeah. Yes, it does work. See that? That works. Beautiful. Sorry about all the mess, guys, but looks like it's working. And see how we wanted to go from, but it's going 3 to 64. It's going 3 to 64. There should be, oh, you never go 3 to 64 because that's the stem. I'm really sorry about this. You don't need this. Inchans is not defined. So inchan is always going to be channels -1. So it's going from channels to that. It's going from 64 to 64, 128 to 128. And then there's going to be a transition block. So how about that? Yeah, it's going from 64 to 64, 2 of those, 128 to 128, 256 to 256. But this one should be 64 to 128, right? I'm just trying to make this a copy of this. So like there's 64 by 64, two of them, but then there's one in between that's 128 by 128. Like this won't work. Why would this work? Because it's not going from 64 to 128. So that's the only thing that I have a problem with. Let me see if there's suggestions here. Channels typo, type in typo. As we build a model, is there a way to display what connections network? Looks like not at the moment. Channels, this is what was that? Yeah, ignore that. That's not needed. That is not needed at the moment. I guess, you know what we could do? I could just take this. And now this is where I will just cheat a little because I'm stuck. I'm really stuck. I won't. I'm really, really stuck. And I'll just copy this. And I'll just copy all of that, copy all of that. If net's right, I don't need all of this. I just need that. Is that even used somewhere? That's right. Where? Oh, okay. I don't need any of this. Downsample is none. In channels, block FN, that's fine. Down quarks is all of that. Downsample average, block quarks, blocks, blocks, blocks that append, blocks that append, stages that append. Okay. So let's first try and understand what's going on here, right? At some point, we're going from in planes to out planes. Okay, so there's the block fn dot expansion. Is this where the fun thing is happening? Is this where everything's happening? Let's see. So you're going from, so you need 4 stages generally, right? You're going from for stage index in channels. So the value of channels was, if we see, where does this get called? So if I press Alt Shift F12, oh, if I press Alt F12, does that give me references? Yes, it does. Okay, so it gets called here. So the channels, the value of channels is this, right? So if I put that there, that's my channels. Sorry, that's just the value of my channels. Block repeats. What is the value of block repeats? Where are you, block repeats? This should be make blocks. So you have make blocks, you have your blocks. Oh, layers. So that's the block repeats. That's like that. And then you pass in planes. So at which point does this go? In planes equals deep stem. Okay, that's all good. So at some point then, this goes from 64. Okay. I see. At which point does it go from 128 to 256? That's my question. So if I go import tim, m equals tim dot create model ResNet 34. If I do this and I print this m, then there's a layer 1. Actually, let me go 18 instead of 34. So then there's a layer 1, which is going from 64 to 64. And then you see this, layer 2 is going from 64 to 128. Like this is what we're missing. I guess if we could add that to our make blocks function, we should be sorted, right? Because the one, like our make blocks function that we have is, if I call this my make blocks, if I call that, we're going 64 to 64, and then this should be 64, like this one, this first one should be 64 to 128, right? You can see here, like 64 to 64, 64 to 64, and then it goes 64 to 128, right? Conf. Yeah, that's all good. 64, 64 by 64. That's my first block. That's my second block. And then goes from 64 to 128. So all I need to do is that 64 to 128. So if I can go, I'm going 64 the first time, then I'm going 2 layers, and then I'm going, instead of like this should be in channel to num channel, and then let me set in channels to be in channels stage index -1. Does that work? That won't work, would it? It's going 64 to 128 every time now. So now I need to make this to be in channels. This, yeah, I must be out of sleep. And then it goes from num channel, which is fine. Which point do I set this up? Guys, I think I'm lost. This is where I'm lost. All I need to do is help me fix this. No, I don't think that would be like, I think I'm just making a fool of myself by taking too long. Like, this is not something that's that complex. Like, this is something I thought I would be able to do, but because I've been away for so long now, that this is something that's taking way longer than it should. All I'm trying to do is like, it should be able to go from, what if I do it like that? So my in channels is this. My all I want to do is I want to go from 64 to 64, and then if the at some point, okay, at some point, if that's not equal, then that's when I want to do. So how about that? Would that if statement just fix everything for me? Yeah, looks like it. It goes 64 to 128, 128 by 128, 128 to 256, 256 to 256. Yeah, I think I fixed that. And then what's happening here? Why is it going from 5 and 2 to? Oh, because yeah, why is it going from 5 and 2? Because of this. If block index equals 0 and stage index not equal to. Does that work? Yeah, 64 to 64, 64 to 128, 128, 128. Yeah, I fixed it, guys. Really sorry for the mess. Okay, really sorry for the mess. It's just all right. See, that was just like I just kept putting the ifs. I think all I needed to do was keep shut for a sec, think for 15 seconds, and I had the answer in front of me. But there's also like, I've also just become very bad. But anyway, what I'm doing here is I've got my layer name now. So what if I do this? So can I say make blocks? What does that return? What does that return? It returns a conf. Oh, yeah, of course. Layer names. Status.append. Layer names dot append layer name. What does that do? I'm just trying to make this work. Okay, so you have conf 2, 3, 4, because your conf 1 is the stem. See, that's nice. Now this is how I like it. And then if I go, so conf 2 is basically this bit. So if I go 1 and then I go 0, see, that's conf 2. Yeah, that's nice. I like this. And then conf 3 is this. Yep. And then conf 4 is this. And then conf 5 is this. Yes, nice. Cool. Okay. Are there any questions on this make blocks function, like what I've done here? This probably is the most complicated part of the whole ResNet architecture so far, but it wasn't that complicated. I just made things really complex. Like the first, so there's literally in every ResNet architecture. I've already fixed this one, so don't worry about this. Cool, you got it working. I know I got it working. Finally, just took me like, I don't know, how much time did I take to fix this? 20 minutes? Oh, it's 11:42 already. Have we been doing this for an hour and 10 minutes? I'm really sorry if we have, but looks like this thing is working. So all I'm doing in this make blocks function is like, I'm enumerating to my layer. So even if this was like 2, 3, 2, 2, this would still work, but it would be a different, like, now we have 3 of these layers instead of like 2 of them. And see how this has a downsample on its own. So like this is just something that's going to work. I mean, if I went from like 3, 4, 3, 4, which is the configuration for ResNet 34, 3463, I think. Is that what it says? Yeah. You have the first block thrice, you have the second block 4 times, this one 6 times, and then 3 times. So if I do that, see, even that works. So like you have 64 by 64, the first block 3 times, the second block, there's 6 of them. Oh, sorry. The second block has 6 of them, and then the last one has like 3 of them. So you can see 0, 1, 2, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, which is 4, and that. So like everything's working fine now, right? Everything's working fine now. And I could put this in an end of sequential, but that's that. So now I can just say self.blocks equals make blocks. You pass in, I'm just going to call this block fn. You pass in your block fn. You pass in your layers. So it should be set up as like that. If you guys don't know this, I'm actually furious at myself for taking this long, but please forgive me for taking this long. And I should be able to do this, right? Self.blocks. The one thing I'm missing is, again, this self.add module, which I quite like. So it's going from this to this. So I should just call this, actually, this is a nice one. So I should just call this stage modules. But if I pass that, oh, yeah. So stage modules is make blocks. So make blocks, what was that returning in this one? In this case, it was returning something like a stages, and stages had a stage name and that. Okay, yep, I can do that. That should be easy to fix. So I can just say stages.append. Yeah, instead of having like 2 things as separate, it could just be called stages.append that thing, stage name. So I can just append a tuple, which is quite nice. Just call it layer name. So instead of calling it layer name, I can call this stage name. And that becomes my stage. Then I can return stages. Okay, so make blocks again. I'm just testing if I have not broken anything. Yeah, okay. See that? That's nice. You have conf2, which is all of this. You have conf3, which is all of that. Conf4, which is all of that. Conf5, which is all of that. That's nice. So now I can just say, I can now do exactly what's being done here. Is I can just say stage modules is this. Stage modules is that, and now I can go pasting. All right. The only thing is that inherited differently. It's nn.module. And now what about my forward? Okay, and then define forward self x, and we can just pretty much copy paste this, all of this. Okay, so you first pass that through your this thing, then you have, why is there a max pool operation here? So what's this stages? So I guess I'm just trying to now implement this make blocks function. So it's conf2, conf3, conf4. So instead of like calling it layer, I should call it conf2, 3, 4. Should that be, instead of this being, should that be that? Am I, what if this, what does this do? Oh no, it should be 2. That's fine. Yep. So then this should be self.conf2, self.conf3, self.conf4, self.conf5, and then what if I return x? Does that work? I'd be damned if it did. So if I call this layers equal 2, this becomes ResNet 18, right? Does that work? Oh, I've got something, guys. I've got something. Okay, ResNet 18 architecture looks like this. Nice. What if I pass in my input? Does that work? Like if this thing works, I'd be so happy. Toss the random 1, 3, 2 to 4 by 2 to 4. Shape. Oh, that worked. Sorry, that was just a moment of happiness. Nice. I'm so happy. I'm sure there's a few mistakes in there, but at least like the basic thing is working. Oh, you want to use this as homework? Well, I think there's no homework left. Like I've just done everything that's needed. I hope like I can only try and explain what's going on here in this part of the in all of this part of the code, but there's literally no homework left. Like now I can just create my ResNet 34 by passing in like a different number of layers. So I should not use this. I should just call this 2 to 2. Let me see if there's any comments on the live stream, which I've been ignoring so far. So let's compare a random code of 3 posts. Okay. If you guys want to use this as homework, that's fine with me. But now, what I've done, what I have in this implementation is like a ResNet 18, and now I could also create a ResNet 34 by just changing the number of layers to 3, 4, 6, 3, and then that should be my ResNet 34. The only difference is like I'm still outputting like the features. All I need to do is add a classifier in the end. So let me do that. Where is a classifier? Is there a classifier? Yep, self.num classes. So where do you get used? All I want to see is this. Reset classifier, global pool, self.fc. Ah, okay. That's why you had the global pool in there. That makes sense. And then there's a bash norm act1. Okay, after this one, cool. And then there's a max pool. Oh, I'm missing the max pool. I'm also missing this one, max pool. Okay. So in my architecture now, so far, I've got my stem set up. So as you can see, that stem, this 7 by 7, 64 stride 2 stem is being set up, which looks like this. This is my conv1 because in the paper it's called conv1. So I've taken the liberty of calling it conv1. So that's what happens. So the first thing that happens is like the input gets passed to the stem. Now I'm missing this max pool. So I should call this another thing is like self.pool equals nn dot max pool, is it? Yeah. Max pool 2D. and it's a 3 by 3 pool, right? So kernel size is 3, stride is 2. So the next thing that happens is that this goes through pool X, and then it goes through all of that. So let's see if that still works. Yeah. Now it's saying name tensors and all the associated okay, I've just put in max pool and then suddenly there's some issue. It's giving me a warning. Toss.max pool TD. Well, that's an internal PyTorch warning. That's something I can ignore safely. Okay. So that's working. I've got this conf2 set up, I've got conf3 set up, I've got conf4 set up, and I've got conf5 set up. And then finally what I can do is an average pool and then 1000D softmax. Okay. So in the end, you have, I can just call this self.pool1. So is that what's happening in here as well? Yeah, you have a global pool. See that? So there's a create classifier function, which we can, let's just use this. I think there's no need to like do anything separately. We can just use, yeah, we can just use this create classifier function from Tim. So where are you? Where's this create classifier function? It is in, but if I use this, I would be cheating, right? Because I wouldn't have done the whole, selective adaptive to pool TD, which is this. Selected adaptive is Tim layer. All right, that's not a problem. So I can just call that self.pool, which is in this case, is there anything it's called? It's just called max pool. So let me just call this self.max pool, and then let me just call the last one as self.average pool. Average pool 2D. Again, is that a stride? No, there's no stride in this case. So, and there's no, yeah, I guess instead of creating the classifier, like all we're gonna do, oh, yeah, all we now need to do is like, everything's ready. All we now need to do, is like, we need to flatten. Remember in when we were doing fast loop, I told you like you can't really like every now network, if my input is different, of a different size, then everything is like the output shapes become different. But we need to have a pooling layer in the end, followed by a classifier. So I can just call self.classifier create classifier function from Tim right now, just to make things easy. Where is this create classifier function? So it's part of tim.models.layers. So let me just, I'm doing a bit of a cheating, but this is not really from tim.models.layers import create classifier. This is like, I don't consider this a lot of cheating. Like this is something that is fine with me. It's not a lot of cheating, so it's fine. Self.num features, what is this? Oh, okay, got it. In our case, it's just always going to be self.num features is always going to be 5 and 2, because that's what we left with. Self.num classes, just call it num classes. Pool type is global pool. So pool type is global pool, which is average. So I'm just going to call it average as well, because that's what we have. And then num classes is that. Okay, now what? Does that work? No? Oh, because I didn't really use this, did I? I just created that, but never used it. Now what? Does that work? Tuple object is not callable. Why? Oh, what? What did I miss? Self.classifier. What if I do this? Does that return a tuple? Oh, it does return a tuple. So it returns a, okay, I see. That's where the, oh, okay. So you just have that, you just select it. Okay, yeah. Instead of like doing like that, you just say something like that, and then you go in the end, which is this one. So you just go global pool, and then you go, does that work now? Cool. And does this work now? Cool. So you can see I've successfully implemented ResNet from scratch. I know it was a lot of pain, but it was a lot of pain, but I hope that in going through all of this pain, I've kind of now helped increase the explanation. I too felt the, I loved when you went, whoa, I really felt the happiness. Yeah, well, I was stuck. Like this is the, I'll be honest, like I've never been this stuck on ResNet before. So this is what happens when you're out of practice. But as long as it works in the end. So I've just implemented ResNet. Now, I guess for homework, or like if you want to build on this, all we have to do is like the ResNet 50, 101, and 152. You just have to have the exact same structure. Like this structure, this is everything that you need. All you need to do is like, instead of like using a block function as basic block, which is this basic block, just replace this with a bottleneck block. See how you can implement a bottleneck block. You just have a 1x1 conf, followed by a 3x3 conf, followed by a 1x1 conf. So instead of like having conf1, conf, and conf2 in your basic block, you have conf1, conf2, conf3, and just try and replace like this basic block with a bottleneck block. And please, please, please post it in the forums. So just try and replace this with a bottleneck block and paste it in, like try and create ResNet 50, 101, and 152. In case that doesn't happen, let me know, and we'll take up, we'll build on top of what we've learned today next week. So this is where we'll stop. And thanks for joining me in my embarrassment as I took that long to implement the ResNet architecture, but hopefully I've been able to explain something that how it is implemented. This was the worst function ever, but thanks for joining me, guys. See you guys next time. And I just need to stop the live coding now. But thanks for joining me. See you next time.